Okay, so there's my 3 cables, all local. Now what I'm going to do is I'm going to take one, SMU1, I'm going to tie it to my fixture, SMU1. I'm going to take SMU2, this guy. I'm going to tie it to SMU2. I'll show you this in a second. SMU3 to SMU3. So what I got here is I got a N-channel MOSFET plugged into my fixture, and I'm bringing the SMUs to the different pins of the device. I'm ignoring the bulk. We don't need the bulk.
The
Okay.
bulk, what is it?
The bulk is the can,
Oh, okay.
basically, right? So this is an SD210. I think it's a Fairchild device. But it's a standard MOSFET. So that's connected. Well, now we got to fix this. Okay, so K-pulse can it run? Well, Clarius is running. Why don't want to run K-pulse?
And you said the grounds are already automatically
They're
connected.
inside. Yeah, they're grounded
No,
inside.
no. Oh, so you're not doing the.
Okay, so what happened here is this came up and it said something's not right. Okay, and that'll happen if you've connected some new hardware that it's not familiar with. Show this so that you can see it too. Okay, that is right.
Okay. So.
So
Channel.
the icons here. There's several icons. Clarius, that's the main software. If you've used that guy, you're used to what's called Kite is gone. Clarius is the software that you run on this. KCON, that's Keithley configuration. We got to do that once, and that's how we fix that error that popped up. So we run this KCON, and what KCON does is it tells you everything that's in the machine. So here's SMU 1, 2, 3, 4, 5, 6, CVU, and a ground unit. The little arrows means you got preamps connected.
Oh, okay.
Okay. Now the cool thing about this is I can select this guy, and if I think there's something wrong with it, I could run a self-test on it. I could do that on the preamps as well. I could open this guy up, go down to the preamp. I could run a self-test. So I could test all the hardware out from here if I want to, right? So it found the CVU. It didn't find this. That's why it complained. It didn't find the CVIV. So what we got to do is we got to say update. So what we'll do, oh, and we got to disconnect our device or it'll blow it. So we say, it'll tell you that. So you say update, it tells you make sure there's no devices connected, blah, blah, blah. And we'll run that. Now what it's going to do is it's going to update this because the Clarius software utilizes the information from this so you can run your tests. Okay? So you'll see it's going to add a CVIV in here somewhere.
Nice.
So now look,
So what
CVIV is
What
here.
are these?
Those are the sense lines for
not the
4-wire.
sensor, okay, 4 sensors.
Well, I'm not going to do any 4-wire right now. But look,
I see.
look now what we got. CVIV is
Yep.
there. So now all your hardware is identified. So now what I got to do is I got to hit save. Now you should never have to do this again unless you take something out or add something,
Yeah.
right? And it'll squawk at you. It'll say, oh, something's wrong.
Yeah.
And then you just run KCON again.
Mhm.
And you save it. Okay? And you get out of here. Okay? And then there's K-pulse you're never going to use because you don't have a pulsar. That's to generate pulses. Cult is an IDE for writing your own tests. So you can write
The automated
you
test.
can you can custom write your own tests.
Okay.
Most of the tests that are in here are already done for you, but if you want to write your own, you can. That's how you use Cult for that. Kixie is for the GPIB. If you wanna talk to this via another computer using GPIB, you'd have to invoke Kixie, which turns this from being a controller to being a listener. Makes it just another dumb instrument, just
Okay.
like any other instrument you got here, right? So you got to run Kixie, and it turns around the bus. Okay, we don't care about any of this other stuff. The Learning Center, this is good stuff. There's a lot of information here. Before you call me, dig in
Okay.
here, because there's a lot of stuff. There's all kinds of information in here for all the different types of products and blah, blah, blah. Okay, so let's get out of there. Oh, I didn't come up twice. I don't understand that. Okay, so here, you got all kinds of, all the manuals are in here, the data sheets. There's even videos explain things like grounding and shielding and all that. It's all in here. Okay? So I'm gonna get out of there. Now, Clarius. That's the main software. I run that. Come on, run. There it goes. Okay, this is where you're going to do your work in Clarius. Okay. Okay, so this is the guts of this machine. There's three things. I'll remind you, this is a touch screen. I don't like the touch screen, but it's all touch screen. It'll pinch and zoom like your phone, all that stuff, right? So you're testing its 3 steps. You're going to select what you want to do. You're going to configure the test, and then you're going to analyze the data. Okay, so it's a 3-step process. So first thing you're going to do is you're going to select. Now, I've got a project already set up over here. It's called the default project. You can create your own. The default project has all my demo devices, right? So that's why it comes up to default.
The VDS.
So
ID.
yeah, so you got your VDS ID, your threshold, linear threshold, your sub VT, you got VGS ID, IGVD, you got CV for a MOSFET, which is gate capacitance. You got pulse, which you don't have the hardware for that, so you can't do that. And waveform measure, you also need the hardware for that. Okay, so what I can do with this project is I can create, I can set this up however I want. Mine is default, so I can have devices. You can see I got different devices in there. And then under each device, I could have different tests. And I can put that all in one project, which probably doesn't make sense, but for this, it makes sense. Like typically, you'll have a device you want to test. That'll be your project, and you'll put all your tests under it. You have another device, you'll create another project.
So you have diode, two-wire resistance, you have diode, capacitor. Okay, that's
So
good.
this basically covers, this is an example for all the different types of tests you're going to be
Do you
doing.
have something for inductor as well?
Inductance is calculated, okay? And that's all done through the CV meter. I can show you that, okay? So here's all your devices. Now, if I go to my 4-terminal FET and I go to VDS ID, that's usually where I start, and I go to configure. Now this is where I set up my test. Okay, so this means nothing. It's just a bitmap. I could put a picture of my kids there if I wanted to. It doesn't matter. What matters is what you do on each pin. Okay, so I could test a resistor from this screen. It doesn't matter. Whatever this shows doesn't matter. What you do here is what matters. So now this has got a little icon that shows you kind of what it's doing. This is showing you a ground. So it's using the ground unit, which we don't have. We're not going to use that. So what I'm going to do is I'm going to say none. I'm going to say none. I'm not going to use the ground unit. This one's showing just a bias, right? So this is, remember I said use the SMU for ground, right?
Yes.
So voltage bias of 0 volts. Voltage bias of 0, that's why I don't like the touch screen when I'm demoing. I do that all the time. So I could set SMU1 to 0 volts, and I set a compliance. Now that's my ground, okay? This is showing me a step function on the gate. So this will give me a family of curves where you get multiple sweeps, right? At different gate voltages. And this is showing me a linear sweep. So for every one of these steps, I'm going to do a linear sweep, complete linear sweep. So first thing is, what hardware do I want to tie to that pin? Now I matched everything to my fixture. This is something you got to be aware of. You got to make sure the proper hardware is tied to the proper pin of your device, right? So this is all set up for me. SMU1 is my source. So SMU1, you see it goes to the source. SMU2 is my drain. SMU2 goes to my drain. Oh, I got to put my device back.
What if you don't, like if I want to measure a device, I don't have that fixture, how do I do that?
Well, use your probe station.
That's
You can
over
get
there.
a triax to alligator clip cable.
Then you play
Oh,
over
okay.
here.
Right, that's one way to
here,
do it.
here, and
Okay.
here.
Or you can, there's several ways you can do it. You could put an adapter on here, convert the triax to BNC, then use a BNC to an alligator clip or something like that. However you gotta do it.
What is the easier solution?
The easiest solution, I mean, you really don't want to do your testing that way. If you can help it, that's
No, we need correct result as well.
you kind of. It's nice if you got shielding, right?
Mm.
You just use cables in the air. If you're trying to make sensitive measurements, it's hit or miss. You might get something, you might not, right? So the best way to do it is to use some kind of fixture that has shielding. Okay, that's a fixture, right? You get it inside the box. You close the door. It's shielded. Now the other thing is I didn't mention is you got to wire this up to your enclosure because this will only put out 20 volts unless you wire it to your enclosure for safety. Okay, so it has an interlock. So when the door's open, it shuts this off, so that nobody can get hurt. Because this could put out 400 volts, so it could hurt somebody pretty bad. So right now, if I tried to turn this up over 20 volts, it'll balk. It'll say, nope, sorry, can't do it. No interlock, because it's not wired. So your enclosure has a switch in it somewhere. It should, right in the bottom. And that switch has to be wired into the back of here. And there's a cable that came with this you should have. It's a gray cable. That's the interlock cable. If you don't have one, I can get you one. So this should be all set up to work. I shouldn't have to touch anything. So that's another warning to you. Try not to mess with these because they work. Leave them alone, right? If you change something, don't save it because you'll be overriding something that works.
So what do you mean?
So
Don't
The
change what?
numbers.
Don't change anything.
Oh, anything.
Leave it alone.
Start, stop, step.
Leave it alone. Besides, this is a good way to test if everything's working, right?
Okay.
Because it's using 3 SMUs at once, right? So basically, here's what you got. You got your hardware. So this comes from KCON. So any hardware that's in this box, you can put on that pin. So you got to tell it what you want to put on that pin. I'm going to put SMU 3 because that's what I'm wired to. Okay, so I could put the ground unit. I could put any of the SMUs. I could put the CV high or CV low. Okay. But since I'm trying to do a VDSID, I want to put the SMU there. So then this is going to be I have a mode. These are all the different modes. So what we know about SMUs is they could be anything you want them to be. It could be a power supply. It could be a sweep generator. It could be a current source. It could be a voltage source. It could be a current meter, a voltmeter. So I got to tell it, how am I using that SMU? In this case, I'm going to use it as a voltage step. I could use it as a current step. I could use it as a ground. I could use it as a list sweep, which you put in a list of values. It goes through the list. I could do logarithmic sweeps. I could voltage bias it, which makes it a power supply, right? I could leave it open if I want. I could do whatever I want with this guy, but I want it to be a voltage step because that's what you do for a family of curves test. I'm going to start at 2 volts. I'm going to stop at 5 volts. With a 1 volt step. So that means 2 volts, 3 volts, 4 volts, 5 volts. I should get 4 sweeps, right? Compliance, that's to protect your device. So you set that's a current compliance. If I'm sourcing voltage, I'm setting a current compliance. If I'm sourcing current, I'm setting a voltage compliant. Compliance is always the opposite function of what you're sourcing. So that just says that the source will not put out any more than 100 milliamps. So it will protect your device. So that's what that's for. Now, every SMU has 2 A to D converters on it per channel. So what does that mean? I could measure voltage and current at the same time because I got 2 A to D converters. So I could say measure current and voltage. Boom, it'll give them both to me. I'm not going to do that here. Why? Because what do we know about gate current? It's very small. What did I tell you about settling time? It's going to take forever. So if I measure that current, I can do it, but we'll be sitting here for 5 minutes for this test to complete. So I'm not going to do that. So we don't care about gate current, right? We don't really care about it. What we care about is drain current. So over here in the drain, I'm going to measure current and voltage because that's what I care about. And I'm going to do a sweep from 0 to 5 volts with a 0.1 volt step. We want more resolution on the drain current because that's what we're concerned with is the drain current. And then this guy is just a ground. I don't have to measure anything. This is just a ground. There's no reason. I could if I wanted to, but there's no reason to. I talked about the speed. Here's the speeds. These have to do with the NPLC settings I talk about. When we say normal, that's 1 NPLC, 1 power line cycle. Fast is 30% faster. Slow is 30% slower. Custom, you can set it to whatever you want. Okay? Sweep delay and hold time. Sweep delay is delay that it adds after every source change. So every time it steps a voltage, it's going to wait that long. That's like if you got a lot of capacitance on your device or in your fixturing or whatever, you might have to wait a little bit for it to settle. So you can do it that way, or you can do it with the NPLC. It depends.
So you're sweeping the gate and the
No, we're stepping the gate. We're
Stepping the
sweeping,
gate, okay.
sweeping the
hitting the
drain.
whole drain.
Okay. So for every step, we're going to have a full sweep.
Okay, I see.
Okay. Hold time is time before any of the test starts. At the beginning of the test, you can set a hold time. Now, the total time of your measurement is 3 processes. There's source timing, right? There's overhead to set the source up, right? I don't know what that is. It's indeterminate. We don't care because this is DC. We care about current and voltage. We don't care about time. So there's timing related to that, and it's going to vary based on range. That's why we don't care. You can't keep track of it. Then there's delays that you add, with like this sweep delay, hold time. Then there's the NPLC, the measurement aperture. Those 3 together gives you your total time. Now, if you want to know what that time is, very simply hit this, report timestamps. And what it'll do is it'll put a timestamp on every measurement. Then you can see how long it's taken, every measurement. That's the only way to do it with the DCSMU. With the pulsar, it's much slicker and much nicer. But with this, it's timing's kind of secondary. We don't really care about timing, but sometimes you do care. And that's where you can see, like if you set the timestamps, if you set the timestamps up, and
showing them.
if you set the timestamps up and you measure very quickly to where you're getting that noise, you'll see it. What you'll do is you'll see the current settle. Right? You'll see that, and by looking at the timestamps, you can see how long did it take for that to settle, and you know how much delay to add, right? If you need to do that. But as long as you keep speed normal, you probably don't have to worry about anything. You're probably good. Okay.
Bulb, you said earlier it should be none, right?
Yes.
It's none or ground,
Oh,
it's same?
oh, that's because I powered it down. I forgot to change it. Yeah, it'll fail when I run it, so I can change it to none.
That's only one. Oh no.
No, yeah. So now we got nothing on the bulk. So this should run now. Now I could go to analyze. This is what I should get. I should get four sweeps, right? I'm gonna run it.
So what is that curve again? Where did you get that curve from? From previous measurement or?
Yeah, it's factory installed.
I see.
Okay, so I have to have these selected in order for them to run. Now, if I go up here to 4-terminal NFET, oh, I'm gonna show you something. This is actually gonna fail, and I'm gonna show you that, but I'll explain it. This is gonna fail. Save changes. What did I change?
So even without hitting run, it took measurement, right? Or
No,
it
no,
just
No,
analysis?
that was already there.
Because
It was
previous-
already there. So it keeps. See, it was run 4 times. Nothing ever gets thrown away. So this was run at some other, maybe at the factory they ran it or something, right? The data's just there. You can turn it off by just clicking this button. You can turn it off. Okay. So, but that's what we should get. But we're not going to get it, and there's a good reason for it. I'll explain it because we forgot to deal with this.
Ah, that's an error.
Right. So that's in the loop, and if I run this now, it's not going to give me anything. Watch.
Yeah, I was actually. Yeah.
It's not going to work.
Mhm.
I'll show
So
you how we
you
got
need to run the cake on again?
No. I'll show you what we got to do. See, it's just junk.
Hmm.
And notice it's taking long because look at the current. It's femtoamps.
Yeah.
There's no current. So that's why it's so slow, because the current. That's why I didn't turn on the gate current. So let's stop that. But okay, so anyway, we got to set this up. Okay, so what I got to do is I got to go back to select. I got to go over here and I got to say CVIV. Once you set this up, you don't have to worry about it.
But why did it go though?
Oh,
like,
wait.
Did we already have that cake on and we recognized that?
It recognized it, but it's not controlling it for the test.
Oh.
Actions. There it is. CVIV, it's got to be configured. CVIV configured. Okay, so what I'm going to do is I'm going to add that. And I'm going to put it up here. I'm going to put it right before the test. Okay, now I'm going to go to that. Okay, so we have to tell it how we want to use this.
Mhm.
Okay, so right now we want to use it in SMU mode. We're not going to use the CV meter. We want to use the SMUs. That's your choice, CV or SMU, right? So we got to tell it, what are we going to do? Channel 1 is SMU, channel 2 is SMU, 3 is SMU. We don't have a 4. So we say open. 4's got nothing. 2-wire or 4-wire? We're 2-wire. Now, the other cool thing here is I can go over here and I can say, okay, channel 1 is my source. And I can type in here, source. Go channel 2 is my drain. Channel 3 is my gate. Okay, and channel 4 is open. Not using it.
We
Okay?
have to do that every time, right?
No, no. I'll show you. I'm going to show you this. Another 2-wire. Okay. So now, if I run, now I'm going to run this, and watch what happens to that guy. Okay. Now it knows. Now it knows, and you can see this. So you can see this. You can see exactly what's going on. So your channel 4 is open. You got a SMU on the gate. You got a SMU on the drain, and a SMU on the source. Now I can use it. Okay. So now that test is there. I would save that with my project. And now I don't have to run it again unless I want to change device, change test type. What if I
Right.
wanted to go do a CV test now? I got to reconfigure that. Okay, but I'm going to show you how to do that in a kind of a semi-automated fashion. So now that's set up. So now I can go back to this test, and I can run this test, and it should work. There it is.
Yep.
Okay. Now I'm going to show you something. Say you just walk up, everything was powered off. This it doesn't know where it's at, right? Everything's powered. See how fast that ran? If I turned on that current, it would run forever. But now what I could do is I could go over here, and I could leave these 2 checked. I could turn off all these other things that are under that device, right? So now what I'm saying is, if I run at this level, it's going to run everything that's checked. So it's going to do the configuration of the CV and the test. Make sense? Then what I could do is I could put another configure, then I could do a CV test. And I could run them all 4, one after, I could run them all together. It will do the change for you, won't it? You won't have to change any cables. It'll run the DCIV test, it'll reconfigure the CVIV, and it'll run the CV test. Okay? So now what I'll do is, instead of running it at this level, I'll go up here and I'll hit run. And now it's gonna go through both of these tests. I don't have, if I pull this up, you'll see what's going on here. See, 200 volts disabled because we don't have that.
Yeah.
So now what's happening is it's updating these tests that are run. So it's running VDSID. So if I go to analyze, now we got another run, and there's the data. Okay? So now I could compare runs. I could, if I want to compare the last run to this run, boom. And you can see, I can zoom in on it to see how close they are. They're pretty darn close.
Yeah.
See?
Can you change the color of? Oh, it's
Yes.
dotted. It's dotted. I see.
You can change, yeah, you can do all that.
Okay.
Yeah. That's the other thing. There's a ton of graphing features in here. I'm not going to go into that because it's just like Excel,
sure.
right? You can do all the same stuff you could do with Excel. So a lot of people would take this data, they pull it off to Excel. You don't need to because there's so many options in here. You could do line fits. You could do linear regressions. You could do searches through the data to find points you look for, like what's the voltage at this current, right? Things like that. You could do a lot of stuff. I'll show you some of that. So there's really no reason to go to Excel. Virtually no reason, because you could do so much in here. So what I'm going to do, I'll show you a test that utilizes that. This VT-Lin utilizes a
So
formulator.
just a quick question.
Yeah.
So over here, when you take CV, IB configure and VDS ID, so it takes CV and IB both at same time, or it
No.
just do?
One after another.
But CV configure is important every time, right?
Yes.
Okay.
Because
IV
that's
is important too. If you're doing CV and you want to go back to IV, you got to reconfigure it for IV, right? So you could do it. You could do it a couple different ways. You could do it, like I said, by checking and running them in a sequence, or you could just go click on it and run it yourself,
Okay.
right? So if I, let's say I'm doing CV and I want to go back to IV, all I got to do is go back and run this test, and just hit run, and boom, now it's back to CV. Now
So did we
it's
also
back
do the
to IV, back
transfer?
to IV. What's that?
transfer characteristics in the last run?
Yeah, you're getting ahead of me, man.
Okay.
Slow down, I got it. Okay, so here. This is now where you can do formulation, right? So what this is doing is it's doing some calculations off of the data that it generated. So it's doing a line fit between these 2 points. Now what's cool is I could grab this guy and I could slide it up and down, and it changes the slope and it changes the data. So if I could play with this, right? But to set this up now, I go over here, and I go to, where is it, test settings, and I go to formulator. Okay. Now the formulator, this is where I could write formulas to do all kinds of cool stuff with my data. These are all the data points that are on this test. The ones that are standard are the drain current and the gate voltage. These other ones were formulated. Start I, stop I, VT, ID fit. So that means there's a formula for each of those. To find them, you go into here. Here's all the formulas. So start I, this comes from the data sheet of the device. The vendor will say, to find the threshold, you want to find the current, you want to find the voltage at 1 milliamp. Or you want to find the slope between 1 milliamp and 6 milliamps. Those were the 2 dots, right? So this is setting this all up, and then this is where it finds. That's why I hate this touch screen. And then the VT is where it finds the threshold, and this is the formula for that. What all this means, you're gonna have to go figure all that out in the manual, right? Because I don't have time to go through all that. But this you can almost read it. It's a linear fit. Right, on the x-axis using the gate voltage, drain current, and it's finding a drain current based off the start current, and I don't know. You
can calculate the threshold voltage.
Yes, you can. There's a lot of things you can calculate here.
Automatically.
Here's some of the things it gives you. Right, it gives you some statistical stuff here: average, max, min, standard deviation. Gives you some trigonometric functions. It gives you array functions. It gives you all these line fit functions. You could even do FFTs on this thing if you want to do FFTs, if you want to find frequency domain information off of the time domain. So lots of stuff here. All of this is it's in the Learning Center. You can figure out how to work all that. There's also examples, program examples to show you how.
Can we
this
have
stuff
the Learning Center copied? Is it a PDF file? The Learning Center.
The Learning Center is.
There's a website.
It's huge. You can get off our website, or
Oh, okay.
or you can this Clarius software you can download on your PC,
Oh,
and then you have the Learning Center that way too.
and that's free.
The whole software it's free. You can go on our website and download. You won't be able to run any tests,
Right.
but you can have it at your desk,
Okay.
and then you can have access to all this. So you can build your tests, your projects and stuff at your desk,
Yeah.
and then put them on a thumb drive and bring them over.
Oh.
Right. That's right. One thing you should understand is you can't hurt this, right? Even if you tie 2 smooths together, they could sync the same amount they could source. So a smooth is 4 quadrant, and that's it. It's 4 quadrant. That means it could source and it could sync, right? So if it could source an amp, it could sync an amp. So you could plug 2 of them together and drive it full bore. The other one can handle that. In fact, it loves it. It'll tell you what it's doing. It'll tell you I'm syncing an amp, right? It'll tell you exactly what's happening. So you can't hurt this stuff unless you tie 2 SMUs together and gang them up on one, right? Then you can have a problem. But these tests that are in here, we set them up for you. They're called ITMs. They're called interactive test modules. There's 2 different types of test modules in here. There's an interactive test module and there's a user test module. The interactive test module we developed, we wrote this GUI, we set all the defaults, we set this all up for you. We gave you what we think you need. And then you could select from what's here. Period. Done. End of story. If that doesn't work for you, you can write your own. And that's a user test module. You do it in C++. We give you the IDE so that you could write your own code. You could set the limits. You could write the GUI. You could do everything, right? That's a little more advanced. If you get to where you can't find a test that does what you need, now you got to write it. Okay. Okay, then you can do, and when you get to that level, you can do anything, including break the machine, because now you got access to the full power of everything this machine can do in software. You can do it all, right? So I'm going to show you how you can tell the difference between an ITM and a UTM. This is an ITM. A UTM would show you a DLL over here. It would show you.
Maybe-
So this is an ITM.
Thank you.
Now, well, let's go back to where I started. So over here we're looking at the formulator, right? So this is where we could do some custom stuff. Whenever you write a formula, it adds another column to your data, right? So you can see the start current, the stop current, the VT, and the ID fit. The only two that come with it are the drain current and the gate voltage, right? But when you write formulas, it's going to add columns. Now your formulas can be written so that you can get one output based on the aggregate of all the data, or you can get a point for every point, right? Depending on how the function's written, right? So that's very, very powerful. This allows you to do a lot of great stuff. I can run this; it should work as well. Let's see. I gotta select it, and then I can run that. This should work on the same device.
So what are you running now?
Yeah, running the VT linear, threshold voltage linear. And then it's going to do the formulation on that. Boom, there it is. See? Okay, it's pretty nice. Then there's this guy, sub VT. Very, very similar test, so no reason to talk much about it. But I can look at just the tabular data if I want, or just the graphical data if I want. I can do all kinds of stuff. Here's where I can set up the data series, the definitions of the axes, and auto scaling, and I can do dual graphs, or I can have up to 8 graphs on the screen if I want, actually. So you can have 8 tests. You can run them all one after the other and display all the data all at once. Then I could loop. I could set up looping at the top level, or I could say run this. If I want to beat my device up over a weekend when I go home, want to stress it, I can set it up to over voltage the gate, for instance, and do that all weekend, and then come back on Monday and then characterize it with regular voltage, see if it damaged it, right? Things like that. So a lot of stuff you can do here. VGS ID, similar. This gives you this does some more calculations of transconductance and stuff like that. This I think should run too. This should run. You can see it shows any formulated values, it puts them on the graph automatically for you. Oops, I probably created some noise there or something.
What is the red curve?
I think that's the transconductance. Yeah, it's transconductance. Okay, so now I want to talk CV. Okay,